Okay, one last thing with circles we're looking at with central angles and inscribed angles. Okay, um, here's a central angle. It's when we've got the center of the circle and two radiuses. This angle right here, this angle of rotation, this would be a central angle right here. Okay, and then an inscribed angle is when I'm going to take two chords. Okay, what a chord is it's going to run from not through the middle, so I've got the radius. A chord is just like this nice little line here. Okay, and then another chord and join them on the outside. So now all 3 points are on the outside instead of two of them on the outside and one through the center. This is what we call an inscribed angle. So I've got my central angle here, and I've got my inscribed angle here. Okay. My central angle is whatever this rotation is, okay? So if this was 80 degrees, then if this rotation out here, then this arc would be 80 degrees too. So the arc is the same as the rotation here. That's what I'm saying with central angles, okay? Good with that? And that's our rule. That's like my theorem with this. The central angle theorem just says that the rotational angle is the same as the angle rotation on this arc on the outside, this outside arc here. And then my inscribed angle theorem states that if I had, like, let's say this was 80 again, then this angle is going to be half of that arc. So this angle right here is half of it. Okay. So again, let me label this, that might actually be better. Let's say this is point A and this is point B. And this is the center, and then let's say this is D, let's say this is E, and this is F. So what this would be saying is that angle ACB is equal to arc AB. They're always equal to each other. That's my central limit rule, okay? And then for my inscribed angle, it'd be saying that angle DEF is equal to half of arc DAE. So that would be my rule here, is that the angle is half of the arc. Again, you could also say that 2 times the angle DFE is equal to the arc. So that would be the same thing, just reverse. So think of it either way. 2 of those angles is equal to the arc, or I just think of half of it. Half of the arc is the angle. So those are my 2 rules with that. And so if I keep those in mind, and I also keep in mind what a diameter is. Again, a diameter is cutting that circle in half, and we can answer a lot of different things. So for example here, if I've got this circle W here, and I know that this is supposed to say X Z, sorry, it's supposed to say XZ. Let's say the arc XZ is 60, so that's 60 right there, and angle VYZ, so VYZ is 40 degrees, so this angle right here, and then this is a diameter. I can find pretty much any other angle that's being formed in here. Okay, so let's look at this. I first got this arc, which means the central angle has to be the same. That means this angle has to be 60. Okay, this is a this is a inscribed angle right here. So there's my angle, which means my arc here has to be twice as big. So this would be 80 degrees. So that's using my central and my and then my inscribed angle theorem for that as well. And that's how that works, guys. So just central is going to be the same. The inscribed is going to be half of the arc, okay? Or the arc is going to be twice as big. The other thing about this, if I look, I've got 2 radiuses right here as well. So that means this angle has to be 80 because of the central angle right here. So that's a nice thing to remember there as well. We can also find a couple other things. I can find this arc, because I know this is a diameter, I know this cut it in half, which that's going to be 180 degrees, which means this angle has to be 100 to make up the 180 rotation for this, which means this arc's 100 as well. Well, that's sweet. Okay. I can also do on the other side, if this is 60, that means this has got to make up the rest of it. So 120 here, which means this is also 120 over there. And then because this is 60, I've got an inscribed angle right here with this arc right here. Again, if you look at it from here to here, that means this has to be half, which this would be 30 at that point in time. And then I've also got another inscribed angle right here with these two that are made up from this arc. So this would have to be 50. So I can answer all sorts of questions just by knowing that it's either the same with the central angle or it's half of that. If I wanted to find these other angles, I'd have to use my triangle sum theorem, which just says that the inside angles of a triangle equal to 180. So I could add these two and minus from 180, which means that would be 40. I could do the same thing on either of these other two. That's perfectly appropriate. So this would have to be 50 to make up that. And then this one here would have to be 30 as well. So, and that's just because of triangles. So pretty much you have every angle taken care of and every arc that's taken care of right there as well. Okay. So that's inscribed angles and central angles. If you want to see them just by themselves, well, yeah, just look right here, guys. This is 80, that's 80. This is 80, that's 40. Okay. Don't forget those. There's one other last thing. There's what we call a circumscribed angle. A circumscribed angle is using these two tangent lines. These are tangent lines here because this line is going to keep on going and intersect at just this one point. So they form 90-degree angles right here with radiuses. If I have this 117 angles, 117, that means that they are supplementary. The central angle and this circumscribed angle are supplementary. So I'd have to go 180 minus 117 to get that angle there. So that would be 63 is what I'd get for that angle. So that's all. The circumscribed angle is just this angle that's outside here that is supplementary with the central angle here. So those two would be supplementary. And so that would be my answer there. Okay, this has been your Math Moment with Mommy. Adios.